Hi guys, I just want to have a brief lesson on graphing exponential graphs. They're actually quite easy once you get the hang of them. So the basic shape of an exponential graph, now just for time I'm going to only label the x and y axis in this example here, but from now on, as you all know, the vertical axis is the y and the horizontal axis is the x. So for a basic exponential graph with this formula, y equals a to the power of x, the graph would look like that. That's a basic exponential graph, like so. Okay, we have an asymptote at y equals 0. So asymptote at y equals 0. Now, I think we should spend some time explaining why we have an asymptote at y equals 0. Let's use a very basic example. Let's just say y equals 2 to the power of x. I know that there is absolutely, and we know as well, that there is absolutely no value of x that would make y 0. None. For example, if I go y equals 2 to the power of 0, we know that's 1. Okay, there's not one value of x that would give me a y value of 0. That's why y equals 0 is an asymptote. It gets very close to 0. So for example, we'll get 0.000000001 and it'll go on for infinity, but it'll never actually touch 0. That's why we have our asymptote there. Alrighty. So that's the basic shape of our graph. This shape that you could see in the corner. Alrighty. Now there are obviously variations of that graph, and let's go through them. Okay, let's go through. Sorry, I had to pause there, some technical difficulties. Okay, so variations. If I have an equation that looks like so, y equals a to the power of negative x. That negative, pen doesn't want to work well, that negative x there means that it's reflected in the y-axis. So if I draw my axes, I'm going to draw our original shape in dotted blue. That's our original shape. I'm going to draw our asymptote, dotted line, at y equals 0. That's our asymptote. Okay? Nice. 0 there. Well, let's just be neat so no one gets upset. There we go. Okay, so our new shape, the new graph that we're drawing, because it has a negative in front of the x, I've reflected it about the y-axis. Okay, I'll label it just so we're accurate. About the y-axis, which means it will look like so. Just a mirror image. Okay, so if I have a negative x, it's reflected like so. Alright, now what happens if I have a equation that looks like so? So this time it's y equals negative a to the power of x. So this time the negative is in front of the a. Last time we reflected it in the, or about the y-axis. This time we're going to reflect it about the x-axis. Make it a little bit smaller. So we'll draw, oops, that's a horrible straight line. Let's draw it again. Get rid of that, the pen out. Slightly better. X, y, I'll again draw our original shape in dotted blue. Our asymptote is across here. Y equals 0. The original shape of our graph, is shown in dotted blue. Our new graph from this equation, like I said before, because the negative is before the a, we're going to reflect it about the x-axis, so it's going to look like so. Okay, it's just a mirror image. And if we compare the two reflections, we could see that when I reflect it about the y-axis, I have a negative in front of the x, and it's a mirror image in the y-axis, like so. If I reflect it about the x-axis here, there's a negative in front of the a, and it's a mirror image around the x-axis. That's the original shape that we have which you could see here. It's our original basic shape, and these are our two reflected shapes, and we'll compare all of them like so. Alrighty. Now let's start looking at the translations. Okay. So our first translation, if we compare this graph, y, and I'll use a real example now, y equals 2 to the power of x versus y equals 2 to the power of x minus 3. Okay? Let's draw two separate axes so we could compare them. That's y, that's x, that's y, that's x. Now we know that there is no reflections because there are no negative signs in front of the 2, which represents a, or the x. In both cases, there is a negative here, but it doesn't come in front of the x or our base. This one here, the first step, as usual, is let's find our y-intercept by letting x equal 0. So we're going to go y equals 2 to the power of 0. So y equals 1. So our y-intercept, will be 1. So our graph looks like so. Okay? So asymptote. In this case, the x equals 0 again to find the y-intercept. 2 to the power of 0 minus 3. Okay? So y equals 2 to the power of negative 3. What I'll do, just for some space, and we'll come back to this, y equals 1 over 2 to the power of 3. Remember, if we have a negative power, we could take it to the denominator. 2 to the power of 3 is 8, so y equals 1 over 8. Okay? So our y-intercept is an eighth. I just should have labeled this one. This is 1, and this is an eighth. Okay, so what's actually happened is because of this 3 here, and because it's a negative 3, I've actually moved my graph 3 spots to the right. And I think it will become clear when we combine both graphs on one axis. Okay? So if I draw my axis here, now just say that's half. That's 1. That's y. Just probably need to move it to the side a little bit. Cool. That's y. And that's x, like so. Our first graph, which is just y equals 2x, 2 to the power of x, we know it looks like so. Our second graph has a y-intercept at 1 over 8, which is 0.125. So that's about here, means it will look like so. Now, over here, ideally, if I was to draw this on a graphics calculator, you would see that these two are very close. But excuse my drawing. But the main point I want to show here is that the new graph, which is y equals, I'll have to move it to the side again, y equals 2 to the power of x minus 3, as opposed to y equals 2 to the power of x, has been moved to the right 3 spots. And the reason it has been moved to the right is because there is a negative 3. Now equation there. Okay, a negative 3. Negative 3. If it was a positive 3, it'll move to the left. Okay? Very good. My last thing that I want to show you. So we've translated it to the right and to the left, horizontal translations. What about vertical translations? This is a bit simpler. For example, let's compare two equations again. Y equals 2 to the power of x and y equals 2 to the power of x plus 3. Okay. Okay, let's draw our axis again. One there. That's better. Another one here. Okay. So y equals 2 to the power of x. Normal shape. Intercept at 1. Asymptote there. This time, in our second graph, because we have a plus 3 there, it moves our asymptote up from 0 to 3. We get the same shape, but now we need to find our y-intercept. So that x equals 0, y equals 2 to the power of 0 plus 3, y equals 1 plus 3, y equals 4. So that is the point 0, 4. Okay, so we could see that by adding a number to the end, if it's a positive number, I move the asymptote up by that number, so this time it's 3, up by 3. If it's a negative, we'll move it down. Okay, now there are a lot of questions that you could do on this in chapter 5D and in the review set and in some of the revision that I've given you for your SAC. So I'm going to put another video up now about how to graph logarithmic functions.